So good day everyone. I am Marine Zingade and currently I am pursuing BTech in Information Technology and I am currently in SEM 3. I am currently studying at SGSIT Indore. So today the topic for our discussion is data structures and basically we will be exploring the foundations of linked lists. Why they are important, what is the use case for them, and why do they exist in the first place. So first of all, what are data structures? So, in a jargonish language, the data structures are fundamental concepts in computer science and programming that define how data is organized, stored, and manipulated in computer's memory. So, this is a very official, official uh, definition. But the crux of this definition is that what is the code that we write? We write code to interact with machines. So code is an interface so the code is an interface through which man and machine can interact. And what do we basically do while coding? We basically manipulate, store, and organize data so that our smaller works and our repetitive works can be automated and computers can do them faster without any mistakes, right? And the basic ideas how we implement this organizing, storing, and manipulation is through having data structures, because data structures allows us gives us the superpower to access data, to modify data, and to manipulate data so that our works and our different errands can be done. And the question arises, how many types of data structures really are there? So actually, in reality, there are many types of data structures like arrays, linked lists, stacks, queues, trees, graphs, and hash tables. And trust me, there are many more data structures. But the main topic for this presentation is linked lists. So this is the central idea for this presentation. And why is that? Because without linked list, many data structures like stacks, queues, trees, graphs, and many other data structures cannot be implemented without the fundamental basic knowledge of linked lists. And therefore, linked lists act as a building block for our progress in data structures further. So, wow, what are linked lists? So that the name sounds familiar, but what are they and how are they structured? So again, that official definition arises that a linked list is a fundamental linear data structure used in computer science and programming. It consists of a collection of nodes where each node stores a piece of data and reference to the next node in the sequence. Linked lists are particularly useful for dynamic data storage and manipulation because they allow for efficient insertion and deletions. So again, this was a little bit complicated, but let us take this definition line by line. So first of all, it is said that a linked list is a fundamental linear data structure. So data structures are of two types, linear and non-linear. So linked lists come in the linear segment because they are aligned in a line. So not necessarily like in a straight line, but uh, but but the main idea is to have them uh, like a chain, you can say. So chain is not always straight, but it is always linked to the next element. So it is a fundamental linear data structure, and it is basically a collection of nodes. So from this line, what we can conclude is that link the building blocks of linked lists, the heart and soul of linked list, are the nodes. And what are nodes? So nodes basically store a piece of data, and they also store a reference pointer. So what does that mean? Basically, a node has a data like an array, like every index of an array has a data. Similarly, a node has a data. But apart from having data, it also has one more thing. And that one more thing is the address, a reference pointer to the next node in the list. So again, it it might be very heavy for now, but a node is an abstraction for now. So a node exists, something like node exists, and in node two things are there. One is the data, and the second is the address, the pointer to the next node in the linked list. And why are linked lists useful? Because you can do dynamic memory allocation, and also it is a little efficient for insertion and deletion compared to arrays. And as software engineers, as computer science enthusiasts and students, it is our priority that the codes that we write are efficient on the client side. Uh, and therefore, there are four types of linked list: singly linked list, doubly linked list, singly circular linked list, and doubly circular linked list. So do not get very much influenced by this. We will be looking at this in the later stages of this PPT. So the most important part of this PPT is that diagrammatical implementation of linked list. And this is very important. This is even more important than knowing how to code the linked list, because this is where the main conception, the main conceptual understanding, the main conceptual foundation of the linked lists are made. And it is through this diagrammatical implementation that I have created. And I hope that it will be a good experience for you to learn through this implementation. So we can see two boxes here and an arrow. Okay, so the two boxes in the left, and in the left box we contain head. In the right box there is something called null, and there is a pointer. So the arrow is starting here, and it is going all the way to the null. So let us understand this one by one. We have just discussed that in a linked list, it is a collection of nodes. They are the building block of linked list. But my question to you is, but my question to you now is, if every node points to the other node in the linked list, then which node will point to the first node of the linked list? So basically, how will the compiler, how will the computer know that from where that linked list is starting, right? So some pointer has to point to the first node of the linked list. Then the first node will point to the second node. Then the second node will point to the third node, third to fourth, fourth to fifth. But what pointer points to the first node of the linked list? And therefore head comes into the picture. So why it is called head? Because it is literally the head of that linked list, and without that linked list cannot exist. So we know the address of head, and in that head we have the address of the first node in that linked list. So we go to head. So basically, when you write head in the code, compiler thinks that okay, now where is head? Okay, here is head. It accesses the memory in which the head is stored, and then in the head column, in the head node, it sees that okay, so the first node of the linked list is there in the memory, for example, hexadecimal of 1122. So it goes to that memory address by going into the head. Okay, and why is it pointing to null? Because simply the linked list is not existing right now, so nothing is existing right now, so head basically points to nothing. So nothing is another name for null. Right. So this is why head is very important, and we will see the significance of null shortly. So what does head do? Head is very simple. It simply points to the first node of the linked list. It makes sure that computer knows where the first node of the linked list exists. Now, okay, so now the hero of our movie is a node, and it has magically appeared here that this is a node in which there is something called data and there is something called next. So obviously from this diagram, we can see that node comprises of two things, data and next. But the most important thing here is the next part. So we have seen that how data is stored. It is like an array that you can store any data, integer, character, um, you know, all types of data you can store, like basically anything. But next here makes linked list differ from arrays, because next contains the reference pointer to the next node of this linked list. But the problem is here, the problem that we are facing right now is that head is pointing to null, and there is a memory allocated here by the compiler node. So node is existing here, but head does not know that node exists here, right? So we have to manipulate the code in such a way that head stops pointing to null, because now we have created a node. So the head thing should stop pointing to the null and start pointing to the node that we have just created right now. And by doing some code, by manipulation in coding and having assignment operators one by one, we can assign the pointer of head to the memory address of this node. So we remove this pointer from null and we drag it down to the node, to the memory address of this node. And this happens in this way. So when we have coded, when we have used assignment operators in C, now the head points to the node. And basically we go into head first, then compiler sees, okay, so head has some memory address 1234, and therefore it accesses the 1234 of the computer's memory, and then it reaches to the node of there. And then it sees that, okay, now this node consists of two things: data is there and the next is there. And what is next? Basically next contains the memory address of the next node in this linked list. But now you may have noticed that the relationship between head and the node is sorted right now. Head is sorted and node is sorted. But this null is awkwardly placed here. And someone may question that why is null even needed? Our only job was to go with head, uh, give compiler the address of head, and then compiler will see that, okay, that head will point to the next node. Then this will go to the next node. So why do we even need null in the first place? Why is there a need of null? So the need of null is there because, first of all, we can only specify till the nodes exist, right? What will be the next part of the last node? And suppose this is the last node in the linked list. So in the next pointer there may be anything. In the next pointer there may be a graph, there may be an array, there may be another node from another linked list. So basically your code will become highly inconsistent, and it may not produce the desired outputs that you may want it to produce. And therefore it is a very, very good practice and a very essential one to always and always point the last node of the singly linked list towards null pointer. So this gives us two benefits. First benefit is that the code remains consistent, the code performs as we want it to, and also while traversing the linked list in the future stages, the compiler will know when to actually stop, because it will see something called null. So nothing exists here, then therefore this is the last node, I have to stop here, and my work is done. But if we do not have a null pointer, how will we communicate with the computer and compiler and tell that, okay, this is the last node? So null is very, very important, and therefore we always point the last node of the linked list towards null. So in this example, obviously this is the first node and this is the last node. So head points to the first node of the linked list, and this is last node as well. So last node points to the null of the linked list. So voila, you have implemented a linked list here, and you have basically inserted a node here. So it may sound very complex right now, but as you practice it, it will be a lot easier. So this is a single linked list. This is a rough example of how it goes on. So a single linked list consists of head. Now head contains a pointer to the first node, and then the node 1 contains data and the pointer to the second node. So compiler knows, oh, now node 2 exists there, and then node 2 contains the pointer to the third node. So node 3 is there, and then obviously node 3 is the last node. So should it point to? It should point to the null. But you may notice that I if it was up to me, I could just have made this in a single straight line, like head, node 1, node 2, node 3, node 4, like in a straight line. But why did I specifically choose to make them in a diagonal manner? It is because the speciality of linked list over arrays, and this is also one of the most important advantages of linked list over arrays, is that you can allocate memory dynamically, and the memory need not be contiguous. The memory need not be contiguous. So you should know, you do not need a large block of memory, large contiguous block of memory like array do, In linked list you can just have this part here in a memory, then this part in the corner, then you can access this part in the corner. So so basically you save a lot of memory in this, because a huge chunk of memory is not consume, and therefore this is a zigzag manner. So head may be in the top left corner of the memory, node 1 may be allocated in the bottom left of the bottom right, then node 2 may be in the middle somewhere, node 3 will be, but we can access them. Why? Even though they're in a random manner, we can access them because node 1 consists the address of node 2, and node 3 consists the address of and node 2 consists the address of node 3. So that is the only reason why we can access all this and we can perform all these operations, because because most important elements pointers are used. So this is for singly linked list, but for but for singly circular linked list, node the last node of the linked list does not point to null pointer. It again points back to the head. So as we can see here, that node 3 points again to the head, and then that cycle starts again. That head points to node 1, node 1 points to node 2, node 2 points to node 3, and then node 3 points again to head, and then this cycle goes on. So this is this is circular in manner, and therefore singly circular linked list. It has a lot of applications. It is so singly so basically it depends on what is the use case and how you are implementing linked list. So this is the basic idea. With doubly linked list and subcircular linked list, the idea remains same. In doubly linked list, only the only, only we store the previous data, previous address of previous node of the previous address of the previous node as well. So here, like for example, in node 2, node 1's address will also be there, and node 3's address will also be there. And same with single circular linked list. In W circular, we just have the previous node data as well. So this was all about linked lists, and this is how we implement it. So just going through it again, a grammatical implementation, we have a node, then head points to the node, and then it points to the null. So what happened here is that head goes to the node, and then node goes to the null. Why did we do this? Because something needs to point to the first node of the linked list, right? And therefore head points to the number 1 node of the linked list. And please remember that last node of the linked list, if it is not circular, should point to null. This is singly linked list in use, and this is singly circular linked list in use. So actually, why linked list? Because as we discussed, it has a lot of advantages. For example, they are very much ideal for scenarios where data size and shape changes frequently, ensuring memory efficiency. When you're dealing with large data sets, when you're dealing with huge data, you just cannot be loose with the memory allocation. Every byte matters. So their linked lists are very much used, and it also eliminates the wastage of memory, because ultimately you can just allocate any memory in the CPU. So there is no wastage of memory. And also there can be in some cases constant time insertions and deletions, which they make them ideal for dynamic lists, because you do not have to traverse them all the time and find the index of that list. So these are basically some advantages of linked list. Why linked list? So the real world applications of linked lists are given here, as we have already discussed. They are very much helpful in dynamic memory allocation. They are also helpful in cache management, because managing cache memory is a very essential part of operating system. And they basically keep track of MRU and LRU items in the computer system. Web browsing history. So web browsing history is an interesting example, because you may have noticed that when you browse web and if you want to delete a page visited, then you just press the cross button there, right? And what it does is, instead of insertion of linked list, it deletes that node from that list, and therefore the other list remains same, and everything differs after you delete that node. It also has sparse data structures, and text editors, for example, also use linked lists to manage different text files, dynamic insertion and deletion of characters. So in conclusion, I would like to say that linked lists are a versatile and valuable data structure in computer science and programming because uh, they they were revolutionary because they allow us to interact with computers memory, and and therefore they become very powerful because we can directly interact with computers memory with the help of linked list. They also have some disadvantages. For example, you have additional memory overhead because you have to also store pointers with linked list. But I think that is a good trade-off because if you have additional memory overhead, but your code is more efficient because of linked list, then it is a good trade-off. Uh, in spite of this limitations, advantage of linked lists such as dynamic nature make them essential tool for solving complex data management challenges. So, in conclusion, I would like to say that in the realm of programming, understanding when and how to leverage linked lists is a valuable skill because using linked lists, you can basically implement anything starting from stack, queue, trees, graphs, anything you want to implement, you can implement with a linked list. So, you should embrace the versatility of linked lists and harness their power in your coding journey to build more efficient and dynamic software solutions. Thank you, and I wish you good luck for your journey ahead. Thank you very much.